All right, good afternoon, everybody. Thank you for coming for this training. We look forward to having a nice time. We are going to move straight into the R basics. Now, before I start, I want to just make a comment. The objective of this training is that by the end of this training today, you should be able to do something definite, something practical in R. For those of us here who are in the office who are working with data, you should be able to use the knowledge that we're sharing in this training session to actually start working with data. The one that is in your official work, you should be able to start doing one or two things. And actually, this is how I've tried to structure the entire series. The theory has to be properly matched with the practice. So I don't want to bore you with too many things that you just, you're just coding, but you can't see the value of what you're coding. So let's commence. Now, what is R? Some of you have a little knowledge about R. And I think you need to look at, a comprehensive definition of what it is. Now, according to the R documentation, a booklet called An Introduction to R, it is an environment. It's a tool for effective data handling and storage. You don't need to write because you have this slide. You have access to all the slides. Yeah, and it's better for you to focus. Writing can be distracting. Because if you want to make a note, just make a. If you have some very peculiar thing you want to know, just note it. Not taking notes of what we are displaying on the screen. So it's also a suite of operators for calculations on arrays. When we say arrays are essentially a collection of data. A collection of data. It's a large collection of tools for data analysis. It's a very large collection of tools. So many things that can be done. So there are many things there within R that can help you do a lot of things in terms of data analysis. Another thing that R can do is draw graphics, plots, all kinds of displays. And this is actually one of the areas of R that makes it to shine among most of the other tools that we have out there. The facility for graphing is so powerful. Not only powerful, it's flexible. Okay, you can design your graphs, just the way you want to taste. And it also has a well-developed, simple, and effective programming language. Yes, R is also a programming language. It is well-developed, very, very, very mature. It's very simple to learn. The good thing about R is that if you have never had any exposure to programming before, R is a language that you can learn within a few hours. You can start programming. Okay, it's also very effective. All right. But having said that, even though it is simple, it doesn't mean that it is easy. It's very simple to learn. You can pick up, like by the time we finish today, if you have never used R before, you can immediately do something with R. But mastering it is where a lot of practice is required. So if you want to master it, you want to really be good at it, and do a lot of things with it, then you have to really take time to start learning and learning and learning and learning. Okay. All right. Now we've already all installed R. Okay. We will not waste time on this slide. Okay. You just know that R can be installed on Linux. I think all of us here are using Windows. Okay. But it can be used on Linux. It can be used on. Can be installed on Apple computers, on Mac systems. I did mention before, when we installed binaries, and it's already compiled programs. That was what we installed. But R is an open source project. You can also download just the source files, the actual source files, and then now compile them on your own. Okay, it's very tedious. It's very interesting. And you can customize your R in a very unique way. In that manner. I've had the privilege of compiling my R before. Okay. All right. Now working with R. The R session. Basically, there are two ways of working in R. You can work interactively. You can work non-interactively. When we say interactive, it means you are typing in an instruction, and then the program gives you a result. Okay, immediately, almost immediately. So the interactive R session is principally operated through the R console, which when you install this, I showed it to you last week. What the R console is like. By the way, if you haven't opened your R yet, just open it now, because you can feel free to even experiment with a few things while I'm showing them on the slides. So R can be instantiated in a shell. When I say shell, like in Windows, we have the command prompt, we have PowerShell. You can start up your R session by starting up what is called RGUI, which was what we used last time. Okay. Then we have what we call IDEs. IDEs are integrated development environments. We have RStudio. There are other IDEs. I think Visual Studio also has an R, a package and all that. Okay. Then when we say the read, evaluate, print loop REPL, this is what the R session is when you're working with it interactively. You provide an input, R will just read it, and it will evaluate it and print it to you, and it's a loop. That's why if you recall, when we discussed it last week, the R prompt. Okay, when you type in something into R and you hit enter, it begins to compute. And once it's done, the prompt comes back again. Okay, so when the prompt comes back, that iteration of that loop has been completed. Okay, so and it goes on like that, and that's why it's called a loop. It's continuous until you exit from R. It doesn't stop. Okay, so that is the interactive R session. Scripting is different. Scripting is non-interactive. With scripts, you write code in files, and then you pass those files into R by whatever means, and then R will do the work for you. It will just read the code and carry out all the orders that you are giving it by way of code. The R scripts file ends with a .r extension. So when you see a file .r, you know that is an R script. So it's just a text file. If you know Notepad .text files, You know notepad.txt. You know it, don't you? Do you know notepad? Yeah, have you ever seen the file .txt? It's just a plain text file. Okay, so it's just like that kind of file, only that the file extension name is different. Then we can run that R script on Windows into the R script command, or not command. Well, it is an executable. It's a program that feeds your R script into R. So when you run it on the command line, R script with the file name, it just runs the R code. Okay. Then also during an interactive Uche, you are ruining my video. Now, R scripts can work also interactively. Okay, you can run source, a function called source, and use that to run an R script. And line by line, the code will run. Okay. So the R console, like I said, is just an application that runs the REPL on R code. Okay. And the input is supplied at the R prompt, which by default is that right angle bracket is the R prompt. I said by default. It can be changed if you want to change it, but no one does that. It returns an output, which is a printout, or it has side effects. So by side effects we mean actions that are not necessarily outputs. Like you can open a file, you can draw a plot, you can download data, those kind of things. Those are what we call side effects, because there's no output coming from it. When you give the command, it just goes and does the work for you, and then returns the prompt to you when it is done. So it's called a side effect. Now, basic R syntax. Please, as I'm talking, if you have any questions, just interrupt me. I'll answer your questions. The basic R syntax. Now, basically, we talk just a little about memory. This is going to be a very basic lesson. We're not going to go into too many deep or technical details. But in computers, we know that computers work with data. Okay. Now, what is even this data? It's just there are values, okay, that we call it the brain of the computer, which we know is the microprocessor, the computer chip, right? Right in there, there are facilities that enable you to put in data into them, okay. And when we're talking about memory at this level, when we are computing, memory speaks about what we call RAM, right? Your random access memory. That is memory. We're not talking about your hard disk, all those kind of things. Those things are not memory when we are computing. That is storage. That is called storage. It's not called memory. Okay. So when we're talking about memory, we're talking about random access memory. Now in R, the data in memory is commonly referred to as objects. Okay. And objects are organized into different kinds of data structures. So it's organized usually in different ways. Okay. But we will not talk too much about how they are organized today. We just know that when you pass in data, moreover, when we're talking about data analysis, you have to be able to organize data properly for it to be amenable to analysis. Now, our objects can be one-dimensional. Okay, if you look at that printout, you see A, B, C, D, E, F. Okay. Now this is a string of letters just going in one row. Okay. or it can be multi-dimensional. If you look at the one below, you can see the same A, B, C, D, E, F, but now they are organized in a kind of two-dimensional form. Okay, we have columns, we have rows, as you can see it. Okay, can you appreciate what I'm showing you now?
Yes, sir.
So the contents, the data is basically the same, but the way it is organized is different in both cases. Okay, and those things you are seeing there in the square brackets, 1, 1, 2, 3. Those are just to show you the rows and the columns. They're only indicating the rows and the columns. Okay, I could have shown it to you in a different way. Maybe I'll give you names, something like that. Okay, so that's just to let you know that data is structured, and the way it is structured gives it meaning depending on the context. Okay.
Yes.
Right. So data types in memory, that we mentioned before, data is stored simply as bits. Maybe one day I'll have the time to tell you more about bits. Okay, so 8 bits make 1 byte. Okay, so just in your mind, just think of it as a number, right? You pass in a number from your keyboard or to whatever means into your program, into memory, and it appears there as a number. Okay, so but to enable use by human beings, those bytes have to be interpreted as types for it to be meaningful to a human being. Okay, so in R, just like in every other computer language, there are always types of data. But we're going to just make it very simple here. We will call them 1 strings, 2 numbers, 3 booleans. Okay, as we proceed, we will go into more details. Okay, but strings are just like characters, just like the one I showed you before. If you combine the characters, it could be like a string. If you say your name, if you want to put your name into a program, it will be put it as a string of characters. Okay. Numbers, we know what numbers are. Booleans are true or false situations. Okay. There's some data. You just want to know, is this thing so or is it not so? Yes or no, true or false. Do you get me? So that is what we call booleans. Okay. So there are others. Okay. There are other types, but the ones we are talking about are the ones that will come from you as an input. These are the basic ones. You can write a word, for example, that's a string. You can type in a number, or you can type in a boolean. Do you get me? Constants. Now, anything that you type directly into a session is known as a constant. Anything that you just type into an R session is called a constant. It doesn't change. Okay? There's nothing is it is not manipulated. It's not altered in any way. So if you look at that this place here. Now, for you to understand what's happening here, this highlighted area is the input. This one here is the output. Okay. So if you type in 64, you can even do it on your own. You just see it. If you type in 64 and hit enter, you get this thing back. You just give it back 64. Okay. Because it's a constant. A string literal can be considered a constant as well, because it is also return unchanged. So if you type hello or hello R or whatever, or hello your name, it will just give it back to you. Okay. Now note that here we have used quotation marks to encompass it. The quotation mark is what tells R this thing is a string. Okay. So booleans can be done similarly, but for booleans, it's just true or false. In R, we use true or false in capital letters, uppercase, all of them. Okay, if you type it with any other case, it will not be a true boolean in R. Languages have different types. Like in JavaScript, is lowercase. In Python, the first letter is capital. So it varies from language from language to language. Variables. Now, most commonly in a given R session, we work with variables. That's what we normally do. We use constants, yes, we do use them, but most of the time we use variables. Now, from the word variable, it's something that changes. It's not constant. Okay. Now, in creating a variable, we assign a name to a particular block of memory. That's what we are doing, right? When we have our memory that we have assigned as an object, we call it objects. We now give it a name. So it's like we are giving it a label. That label is what makes it a variable. Now this is just a convenience to allow the user or programmer to remember, some part of his or her session. Okay, and also it helps you to avoid repeatedly, putting in a constant. Assuming you have a page of code where you use, let's say, the number 5 in different places. Instead of typing 5 every time, you give it a variable. You can even put it into a name called 5, and then use that one all over the program. Okay. So if tomorrow you decide that no, you want it to be 12 instead of 5, you only need to change it to where you first labeled it, instead of going through to start searching for everywhere where you put it. Okay. So also they make the code expressive. When you write good variables, you can use it to express a lot of ideas in your code. Okay. Now in R, you have to be aware of case sensitivity. See these three, they are all different variables. Okay. So if you create a variable like this, VAR, all of them is small, and you now go somewhere and type something like this, while you are trying to refer to this to give you an error, because the spelling though the same, the case is different. This one here, same thing. This one has a capital R. So all these three are different variables in R. Some languages allow it, but R doesn't allow it. Now, naming rules. There are some rules that you need to observe when you are creating variables. A name cannot start with a special character. By special I mean wildcards, things that are not distinct, that are not regular letters. Okay? Yes. You cannot start it with it. But yes, I said there are special characters. Like in the English language, we have the alphabet A to Z. Those are regular characters. Yeah, we have special characters like dots, comma, dash, the asterisk as a star, hash sign, the @ sign, all those things. You can't use those things in a variable name. In fact, in R, you cannot. The only ones you can use, the only special characters that are allowed are the dot and the underscore. You can't use them. You can't use other ones in any part of the variable name. But to start the name, you can only start with. You can only among the special characters, you can only start with a dot. Okay. You cannot start with the underscore. right? You cannot start with a number, but you can have a number anywhere else in the variable name. You can have it in the middle, you can have it at the end, but not at the start of the variable name. Okay. Then we have uppercase, small case, camel case, snake case, Pascal case, any kind of case. They are all allowed in R. Okay. Now, but the advice is that whatever case you are using, try to be consistent in any given script, or maybe in a package you are doing, or maybe there's a large code base. Maybe like now in this office, you are now using R a lot. It's good for you to have a convention, like an agreement on how you're going to be naming your variables. So, for example, if you are naming an ordinary variable, okay, and just an object, you can just say, okay, let them all be lowercase. Maybe if you're naming a function, you can say, okay, let all the functions be named with a snake case. Okay, so, but if you're writing code on your own, make sure that you decide how your own convention, how you want to, because tomorrow when you come back, you don't want to be confused. Now here are some examples. Okay, the first one we have X is the name given to some string. Okay, it's allowed, but it's not a good practice because there's no context really. Okay, the second one, you see useful string is the name given to it. This is good because just by merely looking at the name of the variable, you can deduce what does it refer to. Now the other ones down there, you see I disabled them with comments. One fig, if you try it now, it will give you an error because you cannot start a variable name with a number. But if it were fig 1, it will work. Okay. Similarly, the underscore mk, if you try it, it won't work. But if you put the underscore behind, it will work. Okay. Now, let me ask you a question. What is the difference between a string and a name?
String has quotation marks.
Yes, exactly. He said that the string has quotation marks. Okay? While a name doesn't. So that's if you observe now. The names here don't have any quotation mark, but this one here has quotation mark. So that is the difference between the two. Okay? Just note it. Okay, now comments. Comments are used, to just put in text into code. You can write a novel if you like, comments. But R will never touch it. You just ignore it. You just jump over it. Okay? So here we have an example here. This line is a comment. Okay? It starts with a hash, so the whole thing is a comment. This one here, there are 2 lines. I was trying to write like a paragraph. So I used even two hashtags here, right? And they are comments. Even if you see them in the console, R is not running it. This one here, this is code, pi. If you know your mathematics, you have the constant called pi. And this one is a comment. From here, from this point to the end of this line on the right is a comment. So you can mix a comment with code like this. So only this part will be executed. Then from here below it will be ignored. Okay? Now operators. Operators, there are so many operators that we use in R, and as we go down, we'll be using them quite often. Now we have arithmetic operators, our common addition, subtraction, multiplication, and division. Okay, so these are the ones that we use. So if you want to divide two numbers, you use this /. Okay. Then we have what we call integral division. Integral division is where if you divide two numbers, if you divide a number with another, if it's not exactly divisible, let's say like there's a remainder. So if you go into decimal points, you just throw away that one. You only consider the one that it was able to divide wholly.
Okay,
without the remainder. Okay, for example, if you want to divide 15 by 4, 15 by 4 will give you 15 divided by 4. Okay, it's 12 with the remainder of 3. So the result of this division here will be that is, it should be 3 only. You will not even consider the remainder. Okay. Then we have modulo. Modulo is where you make a division and then you now consider the remnant. Let me light this thing. Sorry. Okay, so the modulo will give you the result is the remnant. So 10 divided by 3, the answer will be 1. Okay. So here we have examples of some of them. First, we create two variables, A and B. Okay, A is 32 and B is 12. So we do A plus B. Okay. Yeah. A minus B. This is the result. A times B. This is the result. Okay. So R is just doing all the calculation. A divided by B. This is regular division. It will go into it will try to be precise. Okay. This is the modulo here. Modulo division. Okay. This is the remainder of that is 8. This one is integral division. The answer is 2. You follow? Okay. Then we have what we call comparison operators. We want to compare two items, two objects, okay, that are numerical. We can use these operators. We have less than or equals, greater than or equals, not equals. Okay. So when you, I know in maths, if you say something is equals, you use it, one equal sign. In R, you use 2 equal sign. Okay, this means exactly equals this.
2 equal signs.
2 equal signs. When you want to compare two things in code, you need to use 2 equal signs if you want to test for equality. And then not equals is exclamation mark with the equal sign. Okay? The result of this operation will always be a boolean. It either be true or false. Okay? So these are examples. Remember, A is 32 and B is 12. So A is less than B, says false. A is less than or equals to B, says false. A is greater than B, true. A is greater than or equals to B, true. Okay. And A is equal to B is false. A is not equal to B. True. Okay? So this way now, without even knowing or remembering what was the value of A, value of B, the computer will store that in memory. And you cannot compare the variables. Maybe somewhere down the line in your program, you want to now make some comparisons. Or maybe even the value may even change depending on what you're doing. So and then you want to now test it. What is the impact? Is it less or it? So you use these kind of operators to now test it. And it will now tell you true or false. And then that result of true or false, you can now use it for another calculation. Okay. Okay, functions. Now to understand computations in R, this is a quote, very important quote. Two slogans are helpful. Because everything that exists is an object, and everything that happens is a function call. This quote is from John Chambers. John Chambers can be considered the father of R. He's the one that invented the language that was used to develop R. That language is called S. Okay. If you want to read more about him, you can. You will know more as we go into R. You will learn more about this person and what he did. Now, for example, if you want to close R, you need to use a function. So anything you do in R, there are functions involved. Even to close the R, this function Q will close R for you. So when you want to exit R, use Q to exit. When you want to check your R version, like we did last time, you need get R version. And remember, the spelling must be exactly like this. It must be exact. There are tons and tons of functions, too many. So you don't even bother to memorize them. It's not something you try to cram, or even start writing down, taking notes. No. Just use it as you learn it, okay? And then there's a system called the help system that enables you to investigate functions, to know how they work and all that. Google is also there. You can visit Google and just ask, okay, say, how do I check my R version? Or how do I check the version in R? If you just type that one into Google, you will see a lot of pages where you can find your answer. Okay? So, R functions, they have a name and they have double parentheses, as you have seen. Okay? And they may or may not have arguments. Arguments are things that you put in between those parentheses. Okay? So like this is a function, okay? This is the name, this is the opening parenthesis, and this is the closing parenthesis. Right? So this is in between these two. You can put in in between these two here, you can put in your arguments. Okay? Depending on the function. So some functions will need arguments, some may not need arguments. All that information you get from the help file. The help file will tell you about the function. Now, these ones that we just mentioned before, the operators, they are also functions, by the way. They are functions as well. But they don't come in this form. They don't have this same form of the name and the parentheses in the conventional sense of it. In the conventional sense of it. But later on, I will show you more about that. Okay? Now the R documentation. We have the R manual. This is the main reference manual that you can easily open while you're in R. If you just type help.start like this, it will open a page. And from that page you can access all the main R manuals. Okay? R was invented, I think, in 1972. Yes, I think 72 or so. So it's been there. So there's a lot of documentation, lots of it. Okay? And the people that use R a lot, and right from inception, mostly have been academics. So when you read some of the journals, they look very academic. So we have Okay, I was about to say something that, well, the R manual, when you look at it initially, it may not make much sense to you. There are only a few things that a beginner will enjoy reading there. But as you go more and more into it, you will find out that that is where you get the reliable, up-to-date information on how R itself works. We have R help. This is the most important to use for regular day-to-day coding. When you're like in the office, doing some work and you just want to quickly check something. You use R help. Okay, you may not necessarily need to look at the manual. Now the R help is what everybody uses. Everyone uses it. There's no time I've opened R to work and I've not used the help. There's no time. And there's always something new to learn. And like I said, there's so much information. It's too much for one person to just store in the head. And it's easy. We forget even the simplest of things. Why I'm saying this is because at times when you're learning this thing, you begin to feel like, will I ever know this thing? No, you will never know it though. Because it's a feel that it's still growing. Even R is still growing. Each update comes with new features. So it's not something that you just learn and then say, okay, I'm the only all and I know everything about it. Okay. So when you want to open the help file, use this help function, or just type question mark like this. Okay, in front of what you want to check, and then there's a mistake here. I was trying to put a question mark here, right here. Okay, if you put a question mark right here in front of this thing and type this one and run it, it will open the help page to explain to you what that function does and how you can use it. Okay?
So trying it.
Yeah, we're trying it now. That's why we have your listen. It's up to you. We're trying. So later on in the series, maybe next time, I'll give you a talk help and show you how you can use help. Help is not very easy to use even for beginners, because there is a way it's structured. If you once you get used to it, it's easy to use. Okay. Any question? I should proceed. Now, importing data. How do you bring data into R? Because data is really what we work with in R mostly. Now, there are many approaches. There are many ways to get data. Many ways. But we'll start with something simple, something more commonplace. Okay. Now, data is taken from a given format and made available to the R session via the workspace. Now, what this simply means is that data already exists somewhere. We're talking about already existing data, not the one you type in yourself. Okay? Somebody has done some work somewhere else and put it on a file. Now you want to pick that content and bring it into R, so you can now analyze it. That's what you mean by importing data. When you bring it into R, there's what is called the workspace in R. That workspace that's console, that's your environment where you are typing in, right? Is just called us. That is the interface where the workspace, is directly represented. So it's a working environment. Okay. In fact, it's called the global environment in R. So in your mind, you can just picture it like the way I always picture it. I picture it like the top of a desk. If you're working on a table, all right, you keep some papers you're writing with right in front of you. Okay, your pen is there, and maybe your pencil, your eraser, your notebook. Okay, and you're writing, taking notes, whatever. So that tabletop is the workspace. Okay, you just use that as a kind of analogy. Now we start with the CSV file. This file this slide I didn't do it well. It didn't render well. These are supposed to be bullets. Now, we will start with CSV files. CSV files are what we call comma separated value files. Comma separated values. These are text files. They are text files where the data is just separated by commas. I don't know if you have ever seen that before. Yes. Now, CSV files, if you open them with Excel, they will appear as a spreadsheet. Okay. So it is commas that are used to indicate where the columns are. Okay. So it's a very common, easy to use format for very simple and basic data storage. Okay. It's compatible with spreadsheet programs like Excel, Numbers. Numbers is the version of the spreadsheet program that you find in Mac computers. Then to import data from a CSV file into R, you use the function read CSV. Read CSV. For instance, to read the data from a file, myfiles.csv, you use this code. Okay. Now this code is not correct. This code is not correct because this argument here is supposed to be a string, not a name. Okay. This string. So this thing ought to have quotes here, either double or single quotes, any one of them is allowed. Okay. Exactly. Now note that we created a variable called myData. So the entire data which we're importing from this imaginary CSV is being linked to a variable name called myData. Okay? So anywhere I'm using that myData in that program, unless I change it, it will be carrying that data along with it. Now if you type this code down, it will not work because of course this file is imaginary. It will not work because unless you have this file in your history. Okay? Alright. So let me just now show an example of this. This is an example of data exploration. Okay? Because after importing data, it, you want to now explore it. You want to explore it. If you import that thing we just did before, if you import, how do you even know that anything happened? You don't know. You get me? So look at this. Here we have the function that is importing the data. This is actually a file which I have on my computer that I've used to prepare this slide. Okay, which I will give to you, for you to play around with. Now, read CSV will read the data, and we create an object called DAT. Okay. Now this function here, ls, is the function we will use to examine the workspace. What is in the workspace? What is on our table? What are our working data? Right. Now these are the working data. Like this A, B, C, B, that, blah blah blah. They're the ones we have been creating all this while. If you recognize this one, useful string, you recall that one now. You recall X, don't you? Do you recall these ones? Do you recall this variable? Yes. We made them before now. So they are still there in the workspace. We didn't delete them. Okay. But this is one we just made now. That. So it's there. Yeah. Now this function called exists. We just test is it there or not? So you may not want to use ls, you may just want to test, is it there or not? You say exists. It's true in this case. Now we have the function called dim. This dim will check the dimensions of the data. How many rows and how many columns does it have? So you see this result here. This 32 is the number of rows. This 12 is the number of columns. Now view data This one will present the data in a table, in a tabular form for you to see it. Maybe just before we end up today, I will just run it for you. Just that I was a bit constrained before coming. The issue of light. I was planning to send you this file before on the Slack channel, so you can have download it and just do it on your own. But it's very beautiful when you do this function, because it just show you everything, yes, in a tabular form. Okay. Now we have the function called call names. This, or you can use names if you have the same effect. This will give us the names of the columns of that table. Okay. It's not simple. You see it now. So these are the names. Then we have the one function called str. Str will give us the structure of the object. This first line says data.frame. Data frame. The data frame is a type of R object. I was telling you about data structures. Okay. Later on, I'll teach you about the different data structures that we have. This one is a data frame with 32 observations and 12 variables. And these are the variables: X, MPG, CYL, DISP, HP, DR, RAT, weight. Are you seeing it? So, and these are the initial values, just the first few, not all of them. And here you see num, int, num. These are the types. So it shows you what type of data are you dealing with. Okay? This one says factor, num, blah blah blah. Okay? But you understand this one much later. Now let's do some analysis with this. We can quickly do some exploratory analysis of the data. Now notice, even though I'm going to show you something here, it's not like every data set you use will follow the same approach. It varies from data set to data set, but the data sets are like, but the way I see them, they're like human beings. Everyone has his own character. And that is where skill and experience comes in for a data analyst. Maybe you start exploring your data, you begin to have a feel about how to pry it open to understand what is happening inside it. Okay. So let's view some statistics. We have a function called summary. Summary will just take the data and give you a summary of all the items. Okay. So if you look at this one here, these are the names of cars. Just give you 111 and it says the total 26. This one is MPG. I think this is miles per gallon. It gives you the minimum. Gives you the first the first quartile. It's called a quartile. It's a statistical thing, right? Then it gives you the median, gives you the mean. Okay, this is like average. Okay, gives you the third quartile, and then gives you the maximum. So this is this is for each of the columns of that data frame, for each of the columns. To just summarize it for you, so you can just look at it quickly and say, okay, if you don't want to waste time, don't want to just see something, average number of this, you can just quickly see it here with this function. Okay. There's not enough space to show all of them. That's why the thing went down like this. Okay? And if you're doing it on your own, you will see it. Then you can use the $sign operator to extract a particular column. Like this is our data frame, right? This is our data here. This $sign, and we saw before MPG. So if with this one now, you are extracting only that particular column. You bring it out. Only it. So this is it. So all the content of this column is here. Okay? Now let's make a variable. We check the workspace again with this function ls. We have seen what is here. By the way, these numbers here are showing you the numbers of items that are there. Okay? 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 This is number 1. This is number 2. This is number 3. This is number 4. Then on the second line, we have 5. We have 6. So there are 6 items here. Are you getting it? So this one here is this one is like a guide, just to let you know an average number of. So this one here, the first one is number 1. This one is number 15. This is number 29. So just give you a rough guide of what is happening there. Now we take that same $ MPG, and then we put it into this. Notice that there is no output here, but it is stored as a variable. But like the last time we ran it, it just gave us the output. But now nothing happens here. Because what we have done here is we have created a variable called col1. I call it col, that's column 1. Are you getting it? And then if you check the workspace again, you see that now there are 7 items here. 4 plus. This is 5, 6, 7. Before there were 6. And you can see that col1 is now here. This is it. Col1 is now there. So when we did this, we created a new variable, and it was placed into the workspace like this. All right. I hope we're not confused in any way.
So the number didn't change now.
No, this number didn't change. Because like I said, this is a guide for the very first one here, only the first one. This is number 5.
Let's count it this way. That A is 1,
this
ABC is 2.
This is 2, this is 3, this is 4.
This
is 5, 6, this is 7. But before there were 6. Let me show you again. Before there were 6. You see, before there were 6. This is 5. This is 6. This is 5, number 5. This is number 6. So 1, 2, 3, 4, 5, 6. So when it is showing you the results, it is running like this to come back and start again on the next line. Go like this and come like that. Are you following? Okay, so if you want to now view the data, you must run this column 1. Column 1. Now run it separately as its own object, and it will not give you the same content as we had before. Okay? So we can now view the data by running the variable name. So once you type out like this and hit enter, it will just give you the results to show you what is inside it. Okay. Now you can get the sum. With this function here, sum, it will just add up everything. You don't need to start.
That's the total.
Yeah, total. This is the total. So if you like let them be 1 million, it will just quickly do this for you and give you the total. Range will give you the lowest and the highest. Okay. So these 2 values here, this one is the lowest, this one is the highest. Mean will give you the minimum. So which is this one, of course, the lowest, as you saw up there. If you say max, to give you the highest, which is this one. Okay? So these are all statistics. The mean as the average. Give you this is the mean. The median is somehow like the mean, but it's different. I'll teach you that one, what it means later. Okay? Standard deviation, which talks about how they are spread. Okay? I'll teach you that one later. This is the value. This 5 norm. I'll give you an assignment later. You go and do this thing. You open this and read what is 5 norm. Okay? This function is a combination of different statistics. The minimum, the maximum, the median, and then what is called the lower and upper hinge, which is the first quartile and then the third quartile. Do you get me? So they're all combined here in one. These are 5 numbers: 1, 2, 3, 4, 5. Okay. So this is just an example. Now plot. We can draw a plot of, if you just say plot, column 1, it gives the plot. So all the values are plotted here. Okay? In this plot. Very simple. So that is what R is all about. So exercise. We're going to do a small exercise before we round up. We've been quite fast. So we'll do a small exercise. But before we start, do you have any questions? No, that's anything you're not clear on, I can answer you now. Or try and answer. Yeah, no, the answer myself.
We do review, great answer.
Huh?
We do review, great answer many questions.
No, if you have a question now, you ask me now. Of course, also, that's why I created that Slack channel. But at times, it's only when you go later on your own, you start seeing issues. You start seeing, maybe you start encountering problems, or you start having some doubts or things you try you couldn't get. That's why I created that platform. So you can quickly ask there. Then we can discuss it. That way too, you will learn more, and other people will also learn. Yes. You get. So you don't have any question now? Alright. Let's proceed with the exercise. So we're going to do an exercise on data importation. I want us to I will do it live. I'll do it live. As I'm doing it, you are free to also do it, alongside. Okay. Alright. So we're going to download the FIFA 19 dataset from this website. This website is. I will post the link. I'll post the link on Slack. You go there and pick it up. Go there and pick it up. Copy link address. So I'll copy the link and I'll send it to Slack so you can open it. And then we start. Let me do this now. I'm trying to. Let me just adjust this thing a bit. Don't want people's names to appear. I don't know where this video will go to. So that's all I'm doing. Let me show you this one. Okay, this is not even solving it because on my own screen the thing is still showing. Okay, I'll just is there a way of pausing this thing? Let me see. I'm trying to be careful here. Show. Okay. I have no option but to just do it. What happened?
So we're not speaking.
Yeah.
Can we see what I did?
Okay. trying to. Okay. Okay, send it down. Yeah, just do that thing. Get out of here. Okay. Have you seen the link? Just open that link. Let me open my RGUI.
Network.
Okay, it's no network, right? Okay, that's all. So, whatever I'm doing, if you have a question, just ask me while I'm doing it, in case you may observe one or two things. If there's anything you want to know why I'm doing a particular thing, just ask. Okay. So,
It's a network going.
what?
It's a network working. No.
It's not working.
I'm not going as well as my answer.
Okay.
So how are we not going to get the link?
The link is of no use now if you don't have network. Because you have to download it in the
It's kind of good.
It's very good. Just keep trying. The thing is, I already have the data somewhere, but I wanted to just show it to you from scratch. Okay. And let me just. I try to now just orient myself a bit. Try to see where I am. So those of you who know a little bit about what I'm doing. Okay. So. So I'm going to still try and do this thing from scratch. Okay, I'll create a folder. Call it exercise. Okay. So now if you look at this, I have a folder now called exercise. This is exercise, the folder. And I enter into it. That's where I want to do my stuff. Okay. I'm right there. Should be. And I'm there. Okay? The link in question.
So that adventures, how do I even get that place in?
What happened?
I want to sign into that workspace.
You can go to your email now.
It's like a long process.
That's too far. Yeah, no. You don't have it. You don't have it. You need to go. Just type it in here. I think the URL is adventures dash in dash r .slap.com
Adventures
dash in dash r. That should take you there. Okay, so this is the link. Now, how far have you gone?
I thought to say we post it on the...
It's there on Slack, on that channel.
FIFA 19 complete.
FIFA 19. Have you seen it?
Complete, yes.
Yes. So click on it. You just take it to that page.
Still,
Okay. The slow network. Now, if you get there, most likely they will ask you to create an account. You will just create the account because you will not be able to get the data unless you create an account. Okay, it doesn't take more than a few seconds to create it. So this is where I am now. This is the page, and I want to pick up this data. Okay. FIFA 19 complete player data sets. 18,000 plus FIFA 19 players. About 90 attributes okay, from the latest FIFA database. Okay. It's 7 months old. Says that download is 2 megabytes. You just click here now to download. But if you want to study more about the link, if you click here, you get more information about the data. Okay. And you will see some of the details here. The columns, this is the source. We're looking at CSV today, okay? So that's why I chose this one. About the file, that's the summary. Then here we have the columns, okay? Then even some initial analysis that was done. You can see them here, okay? I see them here. All right. So I'm going to download it now.
should I ask them?
Yes, download. Download. Download has started. I'm wondering where it is downloading to. I will still find it.
I should register with my email.
Register. Register. Okay. So ask me where I will save it. So I think I know where I want to save it.
Using my email password, or can I change the password?
No, use another password. Never use your email password anywhere else again, apart from your email. Understand? Well, this is the for the exercise. I want to download it here. Is it finished? I don't know. Okay. Almost done. Okay, so it's done. Now this is a zip file. I hope you know what a zip file is. It's a compressed file. So if I look at this, let me use another function. This file, it does the same thing as the other one, dir. In this folder, you can see that FIFA19.zip is there. Okay. So what I want to do now is I want to extract the data in this file, and I'm going to check. I don't remember how to do it. In fact, I know I use the function unzip, but let me see. Zip file is missing. Okay, so I want to check the arguments of this function. So this is one way of quickly checking, instead of opening the help file, I just check the arguments. Zip file, files, blah blah blah. Okay, this file should be the output file. List first. Alright. Okay, so I'll say unzip. And I'll say file. Data.csv. Again, say FIFA.csv. If you have any questions, just ask me maybe. Because the file was not found in the zip file. Okay, so I may have to open this help file. I have to open the help file because I can't remember what to do here. Like I was telling you guys, help is always what we do. So I'm opening the help file. See how I did it? Question mark unzip. Opening the help file. By the way, the help files they're locally, they're local. Even though it's open in the browser, the file is already on the computer. It comes with your R installation, so you don't need to be online to see the help.
Teacher, have you been able to install it?
Send this one.
What is the issue?
Separate account.
Okay, the path name of the zip file.
That's my one. I've found the using, but when the get started, it's not. So it's not. No access.
Return value.
really understand.
Okay. Let me try it now. You can follow me and leave this in if you can't listen. So you learn more from watching me. Okay. You can always try later on your own. Path name of the zip file. The character vector of the correct file has to be extracted. The default is to extract all files. Okay. Return the list history. If this is true, it's that frame with columns, name, length, and dates. Okay. Directory to extract files to. Okay, so here we have our data now. I have extracted the data with this function on zip. Okay. The only argument that I need to put was the name of the zip file. Okay. So that was done successfully. I'm going to remove this zip file because I don't need it anymore. Okay, I'm going to say on link. And if I say this file again, you'll find that only this is left. Okay. All right. Now, we have unzipped the file into the folder. Now import into R with the name FIFA. Okay. Now this is a CSV file, like I showed you, right? And let's check our workspace. What do we have here? Nothing is there. When you see characters, it means nothing is there in our workspace. Okay. Now I'm going to import this thing. Do you remember the function that I used to import from the other CSV file in the example? Okay. Now, we said in the question here, import into R with the name FIFA. So I'll say FIFA, put the assignment operator here, and I'll say read CSV data.csv. Then it's working now. And then it's done. If I now check ls again to see what's there, we now have something called FIFA. Okay, just watch what I'm doing. Don't worry, you will have the recording. You can always check it later. So we have FIFA there. Now we're going to explore FIFA. Check if there's a variable called FIFA, which we have done already. Now check the data type of FIFA. What is it? Now I haven't talked to you about this before. I actually didn't want to talk about it here, but let me just do it. There's a function called type of that tells you the type of the data. Okay? So I put that in here and it says list. So this is the type. Okay? Right? Don't bother about the meaning, just know that this is the type. Okay? Alright. Now the next slide. Okay. Check the dimensions of FIFA. How many rows and columns are there? Do you remember the function we used before? Dim. Okay. So dim will give us 16. So this dim FIFA has 18,207 rows and 89 variables. Okay. Now the next one says, look at the data types of the column of FIFA. What is the fourth column and what is its data type? Do you remember what we did? Even if you don't know, no problem. I was surprised if you remember. The function called str will give us a structure. Okay, so this is the structure. Whether we can see all, I don't know. There are so many here. There are 89 of them. Okay, we said what is the first? We said the fourth. The fourth. Yes, what is the fourth column and what is its data type? So the fourth column is 1, 2, 3, 4 age. And then this is the type int. Okay. Now, regardless of how I did it, this is just for now. What I did now is not programming. We're just showing it to you because there's a way to get this answer programmatically. Do you get me? Where you write the code and it will give you the answer. Okay. This is the fourth one. This is the type. Do you get me? Okay. Now view the first few records of the data set. There's a function called head and tail, which is there in the slide. I don't know how we skipped it. Just like we are rushing. So if I say head FIFA, it will give me the first 6 records in this data. See 1 to 6. Okay. Then the ID, the name. You see Lionel Messi, Cristiano Ronaldo, Neymar Jr., De Gea, their ages. This is the photo. This is the photo. This link will take you to their photograph, their nationality, the flag of their country, overall points, potential, the club they play in. Okay, so those are all here. Okay, all the stats, or all the variables rather, are here. Okay. Then the tail will show you the last 6. FIFA. So these are the last ones. Okay. You can see it here. Okay. Okay, good. Yes. Okay. Now, how many records were you able to see in each of the above? The 6. Yes, sir. Right? As you see. Now, if you wanted to view up to 10, what would you have to do? You don't know. You cannot know. Do you get me? Yes, sir. There's no way you can know. The only way you can know it is by checking. You check. Now, if you check the help file for head, because head shows us 6, right? So it's either you check the help file or you go to Google and check. How can I check more than 6 rows in R? Do something like that. I'm going to use head because I know that it's something like that is there to give me the function details. Okay. Yes. Now it's opening it now. Then you check. It said return. This is head. Okay. This is the function. Return the first or last part of an object. Description. It shows you the function, its usage, arguments, and then you can now, if you now look at this, you say arguments, an object, n, a single integer, if positive or 0, size for the resulting object. Number of elements for a vector, including lists, rows of a matrix or data frame, or lines for a function. If negative, all but the n last first number of elements of X.
The vectors are the 5 norm. Are they?
No. The vector is a type.
Okay, and the range.
Those ones, they are all vectors. I've not taught you about vectors, so you won't understand what this means now. But what I'm trying to show you is, if you look at this thing, it says the number of elements for vector, for row matrix, for data frame, whatever. How many of them? If you put in this thing here, it will give you how many of them. Okay? And then maybe you can look at examples. You may see something like this now. You see head letters n equal minus 6l. Head Fini.x n equals to 10l. Okay, so we can try out. We say we want to see 10. So if we now say head FIFA, and we say n equals to 10l. We say 1 to see 10. So it gives us 10 instead of 6. So you can actually determine maybe you want to see more. You cannot change the argument here. You change the argument to just show you, give you the option. Okay. So these are the first 10. If you want to see the last 10, you use tail. Tail. FIFA and equals to 10L to show you the last one, the last 10. Okay. All right. So this is where we end the lesson for today. You have seen we have gotten to the point where you can actually take data that has been installed in a CSV file and extract it and put it into organization. You can now go through it. You can, like this one now. You can practice the other code on this very data set. Maybe the player now. You say, okay, now let's say you want to check the column names, so you know which one to pick. Column names of FIFA. So just list them out for you here. So you say, okay, now maybe average weight. Okay, what is the average weight? Average weight of a player. This is weight, or average height. Anyone, right? So if you say FIFA $ weights, this will give you the weights. Okay, but this will not work. This will not work. We cannot do this. Use this one as this now to do this calculation. The reason is because this type is not a number. It's not a number. If you check the type of FIFA $ weights, you see, I haven't even checked this thing myself before. It's a type of will give you the type. Okay, it's integer. Now, this integer we're talking about here is not a proper integer. If you say, sorry, I'm not going ahead of you a bit, but you will still learn all these things. Is it a factor? I'm checking if it's a factor, which I think it is. It's factor. It's true. So I cannot use this as this now to do that calculation. Okay. But if I want to find the ones that I can do that calculation with, I'm looking for numerical stuff, right? So we'll use str again and to check the ones that are numerical. Okay. So let me see. Let's look for it. this data here is very interesting. We're going to work with this thing a lot, because there's a lot we can do with it. By the time we come next time, I'll show you more. Okay, so basically, let's say you want to say the average let's say ball control. Okay, let's now say the average ball control. So now say mean. FIFA. Ball control. Ball control. Just the mean. This will give you the mean. It's just NA.
So why are you always adding the dollar sign?
Yeah, that is the only way to extract that column. That's the only way to extract that. We're focusing on the column. If I say FIFA, if I say mean FIFA, it will not work because we're now dealing with the whole data. Okay, so how do you want to work with that? Okay, it says the argument is not numeric or logical. Okay, so it can't work.
But it eventually gives you the answer, which is NA.
Yeah, but yes. And I mean, it couldn't do anything with it. Now, but even when I did this one, it gave me NA. So, with from experience, I know that something may have happened here. Okay, but for you now, as a new person, you may want to check me. Why is this not give me any mean? Okay. In fact, you can even do that summary that we did before. You know, we did summary like this before. But this data is a bit large, so it may be difficult to read. Okay, it means going through them one by one, finding it. That's not good practice. But I can say summary for only one. Summary for that very one I'm looking for. FIFA dollar sign ball control. See what it has given me the summary only for this one. And look at the summary here. Minimum is 5. The maximum is 96. And then the first quartile, the median, the mean. But look at this one here. N is 48. Right? These NAs are the missing values. They are missing values. Now, if you look at this document for this mean, you will find out that this function does not want missing values. Do you get me? If they're missing values, now let me show something here. Value. If trim is 0, the default, the arithmetic mean of the values of x in x is computed as a numeric vector of length 1. If x is not logical, corrects into numeric including a or blah blah blah. NA real is returned with a warning. Yeah? So those NAs, like I have the idea, the missing values are what made this into not return. So what you do is, this argument here says a logical value indicates whether the NA values should be stripped from the computation before it proceeds. So if we do that now, it will solve our problem. So if we say mean FIFA, mean FIFA ball control, just NA, right? We will now say NA remove. NA remove. We say it's true. From what we saw in the documentation. So it now works. It gives us this thing. So this is the mean ball control. Okay? Yeah. So just example, if you want to plot it, you can equally plot the ball control. There's something I'm doing here which I don't know if you have noticed. That it's not a very good practice, and it's not very convenient. Did you observe that I've been typing this thing over and over again?
Yes, sir. Yes, instead of marking and
I could have just created a variable make it easy for me to type. So I'm typing it every time. Okay. So this is plot. This plot will give us to plot it for us. So this is the plot for the ball control. Okay. All right. Do you have any question? Not yet. Okay, great. So thank you very much for your time.
Thank you very much, sir.
And look forward to see you next time.
Thank you very much, sir.
Bye.